Hello everyone, this is the first lecture of week 15, the final week of the course. And during this lecture we'll consider non-homogeneous linear systems. The system is non-homogeneous if we have some additional vector function here, f of t, which is non-zero. And let me remind you that in these systems we also include second order non-homogeneous linear differential equations with constant coefficients, which we've studied during the first part of the semester. And as you remember, to solve second order non-homogeneous linear differential equations with constant coefficients, we write the solution in the form of solution of homogeneous plus particular solution. And the same thing works here. So the vector, which is solution, is solution of homogeneous plus particular solution of this system. And how we can find this particular solution? As you remember, for these equations, we consider two methods: the method of undetermined coefficients and the method of variations of parameters. The same thing works here. So the first thing, we will look at the method of undetermined coefficients. So in this method of finding particular solution. In this method, we find our particular solution in the form of the function, vector function f of t. So for example, if f of t, let's say e to the 2t times some vector a, then particular solution we also write in the form e of 2t times some vector, another vector b, which is a unknown vector which we need to find, substituting the vector into the equation. If, for example, f of t is, let's say, t squared, some vector a, then xp of t will be b t squared plus c t plus d, so in the form of polynomial of second order. So here the polynomial of second order, and here as well. But the coefficients now, not just numbers, these are vectors. So the difference between just linear differential equation and systems, that the coefficients are vectors, some unknown vectors, that again we will find to substitute this particular solution into the system. If, for example, f of t is, let's say, sine t times some vector a, then our particular solution will be b times sine t, but also we have to add cosine t. So similar to the case of linear differential equations. Okay, but sometimes our vector function f can have different entries, for example, entries of different type. For example, f of t can be, let's say, maybe t, maybe e to the t here, and t squared here. Then our particular solution must contain all of these types. So it must be vector, let's say, a e to the t. It must be also second degree polynomial, and the first degree polynomials all together, it will be second degree polynomial, let's say b t squared plus ct plus d. So your particular solution must contain all types of the functions that we'll have here. This is because of this one, and this is because of this one and this one here. For example, another example can be if, let's say, our vector is, let's say, t and sine t, then your particular solution will be, you must have linear function like t is a linear function. Okay, let me write it here. Particular solution will be linear function, so a t plus b, and also must contain sine and cosine, so c sine t plus d cosine t. Okay, what about the question as we had in linear differential equation, if let's say, if we have e to the 2t, if this 2 was the root of characteristic equation, or in other words, if we already have such thing in homogeneous solution, what should we do? In linear differential equation, we just multiply it by t. Here we have to multiply by linear function where the coefficients are vectors. In fact, I'm not going to stop this and I'm not going to go very deep into this. We will just solve several examples, and solving your homework you will see how it works. So let's now look at an example. So we are given such differential system of differential equations. Let's solve it. So the first step, we solve homogeneous. So what we do for this, we find a minus ri, the determinant, and make it equal to 0. So this is 1 minus r minus 2, 2, minus 2, 1 minus r, 2, 2, 2, 1 minus r, and this is 1 minus r cubed, minus 8 minus 8, minus 4, 1 minus r, and I think there are 3 such things. So here again minus 4, 1 minus r, minus 4, 1 minus r. This must be equal to 0. So this is the same as 1 minus r cubed minus, how many 1 minus r we have here? 4 times 3 minus 12. 1 minus r minus 16 must be equal to 0. And here, so what I can suggest, you can open the brackets, of course, and you can try to solve the cubic equation, but maybe instead it's easier to solve, to substitute 1 minus r is t, so we get this cubic equation. Why I said this is maybe easier, because I already see the root here. When t equals to 2, so it's minus 24, maybe when t is minus 2, right? So when t is minus 2 will be plus 24, minus 8 minus 16 is also 24, so minus 2 is a root. So this is the same as t plus 2. It should be factorized like this, and something squared. Let's see what squared we can get here. This is t squared and plus 2t squared, and we must get minus 2t squared because we don't have any t squared here in the polynomial. So overall they must be cancelled. Therefore we must have minus 2 coefficient here. How many t we have? Minus 4t, and we must get minus 12, so minus 8 will be additional 1. So we got this thing. And also we can factorize this bracket inside, t plus 2, and this I'm sure is t minus 4, and is it again t plus 2, minus 8 minus 2, yes, it's correct. And so this is in fact t plus 2 squared, t minus 4 is 0. Or if we come back to r, t plus 2 is 3 minus r, so 3 minus r squared, and t minus 4 is 1 minus r minus 4, so it's minus 3 minus r is 0. So the first eigenvalue is the same as the second one because we have square here, this is 3, and the last eigenvalue is minus 3 because of this bracket. So we have two repeated eigenvalues and one eigenvalue is different, and for each eigenvalue we must find one eigenvector. So let's write a minus 3i first, apply to some vector u, this must be 0, so we need to find this vector u. A minus 3, this is a matrix which is minus 2, minus 2, minus 2, minus 2, minus 2, minus 2, so all of the rows are the same. Apply to the vector, let's say u1, and this vector is, let's say, x, y, z, must be 0. So in fact from this system we get only one equation, x plus y plus z is 0 when we divide by minus 2. So we can choose two variables to be parameters. So if let's say y is s and z is t, then the vector u1 is, maybe let's call it just vector u. Let's call it just vector u, because u1 and u2 will be corresponding to r1 and r2. So vector u is x is now minus y minus z, and y is s and z is t, so minus s minus t. Y is s and z is t, z is t. And we can write it as s times minus 1, 1, 0 plus t times minus 1, 0, 1. And so we can choose two linearly independent vectors corresponding to each of eigenvalue. So the first vector will be minus 1, 1, 0, the second vector minus 1, 0, 1. So what we need to find now, the third eigenvector. So when r3 is minus 3, a plus 3i applied to vector u is, so it's 4, let me just look at the matrix again, it's 4 minus 2, 2, minus 2, 2, it's minus 2, 4, 2, this is 2, 2, and 4. And this applied to, let's say, some x, y, z again, this must be 0. Just let's check the matrix. Okay, so what we can do now, of course, one of them, of these lines must be linearly dependent, so we can choose just two lines. So, and let's divide by 2, so 2x minus y plus z is 0, and minus x plus 2y plus z is 0. So we choose first and the second row. You can check that in fact how we get the third row, just summing these two, we get the third one. Okay, how we can find something from here? Let's say we can multiply the second equation by 2 and add to the first one, then we will get rid of x, and here we get 4, so 3y, and here we get also 3z is 0, and so y is minus z. And also we can in fact take difference of these two. Just to get rid of the z here, we get 3x. So this minus this, this minus this, minus 3y is 0, so x is y. So one of these can be taken as parameter, So let's take, let's say, y to be parameter, doesn't matter, and then u will be x is y, so s, y is also s, and z is minus y, so minus s. So this is s, 1, 1, minus 1. So what we did now, we just find solution of homogeneous system, right? So we just found homogeneous thing, which is c1 e to the 3t. The first eigenvector, let's have a look at the first one. This is minus 1, 1, 0. Minus 1, 1, 0 plus c2 e to the 3t, and the second eigenvector is sorry, wrong way, minus 1, 0, 1 plus c3 e to the minus 3t, 1, 1, minus 1. This is just solution of homogeneous. This we already know how to do, just repetition for you. And now we need to find, we go to second step, we need to find the solution of, particular solution of the system. So let's do this. The second step, find particular solution of the system. And we find this particular solution in which form? So we look at our vector f. So we look at our vector f and we see that this is just t times some constant vector. So this is linear polynomial, right? Therefore, the form of our xp will be linear polynomial at plus b, where this a is some vector. We have three-dimensional space, right? So this is a1, a2, a3, and b is also a vector, b1, b2, b3. And how we find this a and b? We just substitute this into the system and find the values. So what is the derivative of this? xp prime, this is just vector a, right? So we substitute into the system, we obtain a is equal to the matrix, what was the matrix? 1. So it's 1, minus 2, 2, minus 2, 1, 2, 2, 2, 1. So 1, minus 2, 2, minus 2, 1, 2, 2, 2, 1. And times the solution, right? So a t plus b plus t times the constant vector, which is minus 9, 0, 18. Minus 18, sorry. Minus 9, 0, minus 18. So from this, we must find a and b. And we do the same thing. We compare the coefficients in front of the same degree of t, the same power of t. For example, on this side we have a, just constant vector, and what is constant on this side? Just b applied to the matrix, matrix times b. So we must get from this that a is the matrix times b. And also we compare the coefficients in front of t. Here we don't have any t. Here we have t here and here. So, and another thing is 0 vector is the matrix the coefficient of t is just a times a plus this vector. So we get these two systems. Each vector is has 3 coordinates, so we have to find all these coordinates. So let's write it as systems. So this one is the same as a1 is b1 minus 2b2 plus 2b3. a2 is minus 2b1 plus b2 plus 2b3. And a3 is 2b1 plus 2b2 plus b3. This one and this is the same as 0 is a1 minus 2 a2 plus 2 a3 minus 9, this minus 9 here. 0 is minus 2a1 plus a2 plus 2 a3 plus 0. The second component is 0, and the third component will be 2a1 plus 2a2 plus a3 minus 18. So we have these two systems. The first, of course, it's better to solve this one to find these three unknowns, and then substitute into this system to solve this with respect to b. So this is what we're going to do. So let's solve the systems, and of course we'll use the method of Gauss-Jordan elimination. For the first one, we just write the first equation. And how we get rid of a1? Here we multiply by 2 and add. Multiply by 2 and add, we get minus 3a2. Multiply by 2 and add, we get plus 6a3. Multiply by 2 and add, we get 18. Then we multiply by minus 2 and add to the third system. Multiply by minus 2 and add, we get 6a2. By minus 2 and add, we get minus 3a3. By minus 2 and add, we get 0. So now we just write the first equation and the second equation, and in fact, what can we do now? Just to make it simpler, we can divide by 3 everything, and then we get 2 here and 6 here. And to do this, to proceed, what we do, multiply this by 2 and add. This by 2 and add, we get 9. And this by 2 and add, we get 36. So a3 now is 4. So if a3 is 4, so this is 8. Sending this, it's minus 2, a2 is 2, and a1, so here we have 8, sending to this just 1, minus 4, sending to this is 5, so a1 is 5. So we have this solution, and now we write these things here, 2, 4, and do the same, finding b. So we just write the first equation, then we multiply by 2 and add, we get the same thing, so minus 3b2 plus 6b3, just different is in here, so if we multiply by 2 and add, we get 12. And then multiply by minus 2 and add, we get the same thing here, but the difference is in here. So multiply by minus 2 is minus 10, and add, it's minus 6. So we can do the same thing. Minus 3b2 plus 6b3 is 12. In fact, we can again simplify this. We can divide by 3 everything. We get 2 here and 4 on this side. And then we get rid of this b2, multiply by 2 and add again. Multiply by 2 and add again. We get again 9. Multiply by 2 is 24, and add, we get 18. So b3 now 2. Dividing 18 by 9, we get 2. So b3 is 2, so b2 now is 0, right? If b2 is 0, this is 2, b1 is 1. Just check this. So from this, all this solution, we get that our particular solution, this is in the form at plus b, so this is vector 5, 2, 4, t plus this vector b. And so we can write general solution, which is just homogeneous that we found before, and particular solution.